Assalamualaikum warahmatullahi wabarakatuh, and a good day. I back to my panels. My name is Muhammad Rasulullah bin Muhammad Khair with metric number CN190159. Today I'm going to do a presentation regarding my final year project 2, which related to analysis of photocatalyst and reaction time effect on the wastewater treatment performance by using pilot scale membrane photocatalytic reactor MPR. I was supervised by Dr. Rais Hanizam bin Madun, and I am from JTKM, Faculty of Engineering and Technology. So basically this research for wastewater treatment is widely explored by researchers around the world in order to keep the environment clean. Nowadays, the development of MPR itself in pilot scale research is a few compared to the lab scale research. However, there are several dye wastewater industries still not following the Environment Equality Act 1974. This research also explores the potential of this MPR on dye wastewater treatment, specifically to study on the effect of retention time and analyze the quality of treated dye wastewater. In order to complete the objective of this study, a build-up of MPR was developed and experiment conducted with 60 liters of dye wastewater samples with 3 types of catalysts that been selected, which were zinc oxide, iron 3 oxide, and the last one is aluminium oxide. The lab analysis was collected from the sample provided. Analysis collected from the sample can provide the properties and the quality of treated dye wastewater. In specific, it can collect pH value, turbidity, conductivity, TDS, total dissolved solid, dissolved oxygen, chemical oxygen demand, and color intensity. The development of this MPR for research has proved that these selected catalysts with optimal condition of retention time be able to treat dye wastewater. Next, we continue with the introduction. Nowadays, rate of the water pollution is tremendous increase, which leads to freshwater storage. There are a few main water pollution, for example, domestic sewage, industrialization, population growth, and plastic and polyethylene bags. Wastewater comes from the wet process of the dyeing industry and is categorized by a high degree of variation in many parameters. And then dyes are major sources of environmental pollution that have harmful effect on aquatic life due to their low biodegradability and strong color and also high COD and BOD value. This MPR is a hybrid system that combines membrane separation and heterogeneous photocatalytic action with interesting synergies in some cases. The motivation for this study research is to present and discuss advanced utility and equipment use nowadays in dye industry wastewater treatment. Photocatalyst is also that uses light energy to drive chemical reaction couples. There are 3 objectives altogether in order to complete this research. The first one is to investigate the effect of retention time of different catalysts. Next is to characterize and analyze the quality of treated dye wastewater, and the last one is to define the kinetic model of MPR's performance. Next, we go to the literature. I stated here some of the literature that I found from my research or from my study. The first one is the type of wastewater. It says that there are 4 types of wastewater altogether, which are permeate industry, palm oil mill effluent industry, poultry slaughterhouse, textile industry, and domestic water. Okay, next one, I will go to the methodology in order to complete this thesis. The first step, I was collected the sample from wastewater treatment plant, which is Maxim Textile Industry at Senai, and then I use all the three selected catalysts, which are zinc oxide, aluminium oxide, and also ferrum 3 oxide. The 60 liter of sample wastewater was used and then mixed with the catalyst. So we got here 3 catalysts altogether. I will separate by 3 experiments, and then it also been run in MPR, pilot scale hybrid of MPR. This MPR covers parameter on the sample from direct reactor and also the sample from permeate condition. After the sample being collected from the MPR, I use water quality measuring kit to find the parameter of DO, pH, conductivity, and TDS. Next, I use the DR6000 to find the color intensity, and also the RB200 to find the COD of treated dye wastewater. All these action been taken in order to follow the rule of EQA 1974. The next one for result and discussion. So the first graph shows a flux graph compared with time taken. Flux is an amount of permeate, which is the after membrane condition, that discharge per time. Its weight was calculated by software that connected with MPR. A direct proportional graph pattern for each experiment with different types of catalyst refers to the permeate sample that continuously discharge for 50 minutes. With pressure of 1 bar, samples being collected from the interval of 10 minutes time recorded to perform water quality of lab analysis. So this graph shows a flux, which is the black one is zinc oxide, the red one is ferrum 3 oxide, and the last one is aluminium oxide. The next one is correlation or interrelation of reaction time and different catalysts on photocatalytic performance. So the first graph on the left side focus on the samples that come up from direct reactor, which is before it passed through the membranes. Turbidity removal, it clearly shows that aluminium oxide shows the best result compared with zinc oxide and ferrum 3 oxide. This due to the characteristic of the aluminium itself that perform in removing the turbidity, or because it is white in color and high surface area compared to the ferrum 3 oxide, which are red in color. Conductivity graph shows a slightly increase from the first 10 minutes to the last 50 minutes. This due to the higher the conductivity, the higher the impurities in the sample itself. For color intensity graph, it shows a slightly increase from the minute of 10 to minute of 50. It also shows a high value, which is 650 up to 800 value of ADMI. This happened because the sample was collected from direct reactor, which is not filtered yet in the membrane. The next one is I will focus on the correlation of reaction time and different catalysts on hollow fiber membrane performance. So this on the right side graph shows the parameters that been that been found in this research. I want to focus on the turbidity removal. It shows that almost 100% turbidity removal compared to the graph C from photocatalytic reactor performance. As we can see here, ferrum 3 oxide and zinc oxide perform in reducing the turbidity, but aluminium oxide, it shows slightly down. This may be because of the condition itself before treated by membrane, by hollow fiber membrane, and then it shows a degradation from first 10 minutes to the last 50 minutes. This may due to the coagulation occurs in the membrane and also reduce the performance of aluminum oxide sample. And then the next one is color intensity. It shows a high slightly increase from the first 10 minutes to the last 50 minutes of the experiment being conducted. This due to the membrane itself that filter, but the color intensity for dye wastewater treatment is quite high compared to the requirement from EQA 1974. So the next one is turbidity reduction. This graph was collected from the turbidity reduction. So it shows that the turbidity was optimal at the first 30 minutes, and it will degrade from minutes of 30 to minutes of 50. This due to the membrane itself that already filter all the substance. Its performance decrease with times. This occurs. The graph of turbidity start to degrade from minutes of 30 until the end of experiment. So this one is the effect and different catalysts on quality of treated dye wastewater. So all these parameters discussed on the best result was collected from each catalyst. The blue one is from output reactor and the orange one was collected from the permeate. So next we go into the conclusion. It can be said that the best catalyst performance was sampled from permeate condition compared to the direct reactor. Performance of sample analysis between these two parameters was sided with permeate condition. However, there were some parameters that show slightly different in the result between direct reactor and after membrane condition due to the characteristic of catalyst and membrane. The percentage reduction of turbidity for the treatment shows the first 30 minutes of experiment give the best result, while a huge drop recorded for the last 20 minutes due to the membrane that filtered substances from the sample leads to the degradation in turbidity performance. The optimal catalyst for this study was aluminium oxide, as it shows the best result in pH value, DO, turbidity, conductivity, TDS, and also color intensity. The best reaction time for zinc oxide was 30 minutes, while the best operating condition was aluminium oxide at 10 minutes of operation. The optimum quality rate of high flux at first 30 minutes, it shows a rapid drop at the last 20 minutes. In overall, MPR performance was succeed in treating dye wastewater as it follows almost all the parameters that been highlighted. However, in terms of color intensity, MPR with UF membrane, which is ultrafiltration membrane, still cannot treat the dye the color intensity. Otherwise, using NF, which is nanofiltration or RO, reverse osmosis filter method, in order to perform the treating dye. I think that's all from me. Thank you.